Found that the time it took in our calculator, we said it was 2.38 seconds. Now, I want to do one last little thing with you here before we continue. All right? Because the next question it asks is this, or the next question they may ask is say, okay, so when is the velocity increasing and when is the velocity decreasing? Okay? So when is the velocity increasing, when is the velocity decreasing? Or when is the object speeding up, when is the object slowing down? All right? So if I were to look at my velocity sign chart, we had a 1.08 and we said it was negative here and it was positive there. If we had our acceleration, we said it was negative throughout the whole graph. I'm actually going to add a critical value of a 0 on that sign chart right there. Why? Say again? I think you said it correctly. It can't be less than 0. This is time, correct? I can't go negative time. And so I can only be positive time. So this is when I threw the object in the air. This is what I did. So if I compare my velocity versus acceleration, what's happening here with my speed? It's slowing down because these are acting against each other. From the time I let go of that object, if I'm throwing it, it starts slowing down right away. Now, not immediately, but it's going to slow down. Okay? Now, what's happening when the object turns over and starts coming back down to Earth? They're acting the same. They're moving in the same direction, the velocity and the acceleration, so it's speeding up. So it's going a little faster as it's returning back to Earth. Okay? Now, that doesn't mean they're the same speeds. All right? But what's happening is it speeding up or is it slowing down? Okay? So that's how we can tell. All right. Let's go to another one. All right, give you a chance to take a look at this one. All right. On this one, it says the cost of producing X items in a factory each day is given by this cost function right here. Okay? Yep. All right. It says to find C prime of X, which we refer to as the marginal cost. What does marginal cost mean?
The cost of producing one more good.
Yeah, the cost of producing that next item. So the marginal cost is producing that next deal. So go find the derivative for that for me real quick. Use calculator if you need to. I'll put it up there in a second. So find the derivative of that function. So there's my marginal cost is what I got. That's the function there. By the way, what do you see that disappeared?
The plus 2200.
Okay, what do you think this plus 2200 represents here?
How much it already costs?
How much it already costs? Okay,
Like overhead fees.
like overhead fees, like fixed costs. Like if I went and bought the machine, all right, doing another item, it's not going to cost me another machine to do that. So those fixed costs right there are not going to be a part of the marginal cost. Okay, and so it asks this: find the marginal cost when 150 items are produced and interpret the result. So basically, what that's saying is, what's the slope or what's the cost of adding that 150th item? So if I go from 149 to 150, what's the price of adding that 150th item? And all I'm going to do is take that and plug that in. So go into our calculator, and I want you to go plug that in right there. So take 150 and plug it into that equation that we just got. All right, help me out. I think you've had some time to plug that in. How much is that next cost?
14.375.
Okay, 14.375. I'm gonna go around that. $14.38 to produce that next item. Okay? So I'm looking at my cost efficiency and stuff there as I'm going. And then I'm gonna go do this last one here. Now, I'm gonna do this a little bit differently. I don't like the way that this one was set up. I'm gonna change it just a little bit. So I'm gonna change this. I wanna do C of 150 minus C of 149. I think we're just off a little bit on that one there. Okay? How is this different than this problem right here?
No longer is the derivative.
Okay, I'm not talking about the derivative anymore. I'm talking about the actual cost. So if I produce 150, what is my actual cost? So this is going to go into the original problem up here. Okay? So I'm going to take the 150 and I'm going to plug it in up here. So I'm going to do that in my calculator. And then I'm going to take a 149 and do the same thing. Okay? And so if I were to go over here, I'm going to go to just my normal calculator. And I'm going to go 0.00013, parenthesis 150. I'm going to cube it. All right, plus 0.002, parenthesis 150 squared, plus 5 times 150, plus 2200. All right. So if I were to do that, if I produced 150 items, it would have cost me $3,433.75. So it would have cost me $3,433.75 minus, I'm going to go do the same thing again, but I'm going to highlight and I'm copying and pasting basically what I'm doing. I'm going to change the 150s to 149s. Okay. So the cost for 149 items is $3,419.44. $3,419.44. And I'm going to subtract those two values. So I'm going to use my calculator to do that. I'm going to come up here and grab this one minus this one. And I get $14.31. Now, how do they compare? How do your answers compare?
Close to a little off.
They're pretty close, all right? Not too far off, all right? Which one of these was easier to find the marginal cost? Finding the derivative was definitely a lot easier than that, correct? All right? Do you understand how this is the marginal cost? I had 149, I had the cost for 149, and then I found the cost for 150, so I'm looking at how much was it for that extra one, all right? It's that slope. If I add one more thing, how much am I adding? It's my rate of change. So my rate of change for an item at this location would be $14.38 or so.
If we're going for accuracy, which one's more accurate?
This one, the marginal cost is we use a lot, so this one's probably a better deal there, all right? If you do this other one here, the one I had, it's a little bit more accurate. If I were to subtract this one, I think it gave me $14.40, which that's only like 2 cents difference. And this,
14.43.
huh?
14.43.
0.43. If you subtracted those. Yeah, 14 point, well, yeah, okay, yeah. I just put 14.4, so 14.3. So it's a little bit off. It's a difference of doing, remember when we average rate change versus instantaneous?
Okay.
So there, because we have the 2 points, we're going to be a little bit off. This is like the tangent line. So that's going to be probably the more accurate one as you're going. And you can definitely make it work a little bit easier. A lot of people do, there's a lot of business, some of you go, well, I'm gonna be a business, I'm not gonna have to do any of this calculus. No, you do have to take a calculus class for business, all right, if you're planning that. And so, and a lot of it's kind of in these ideas here, right? Everybody okay? So we did a horizontal motion on Friday, we did a vertical motion a while ago, and now this is just another application for derivatives as well. All right, take a look, turn the page, I believe, or you're on the next page, or you have to flip the packet over. All right, so this is where we're going to talk, next couple of days, we're going to talk about curve sketching. All right, so an increasing function as x values increase, y values increase. That would be an increasing function. As x values increase, y values decrease. That would be a decreasing function.
What if it's like a parabola where it's both?
We'll look at that as well. Because you can have both of these happening in the same function. It's not just one function there. All right, increasing part of that function, I guess you should say. Y values stay the same. So when I write that out, the thing that gets annoying to me, all right, the x values are increasing. I wrote that the whole way through. So what does it mean for the x values to be increasing?
Positive slope.
Okay. How does x move my graph?
Right.
To the right and to the left. So if I'm increasing, I'm reading from left to right, which is how I want to read a graph. And then depending on what the y value is doing, it's doing it. And you're right, if I have an increasing graph, then the slope is positive. If I have a decreasing graph, then my slope is negative. If I have a constant graph, then my slope is zero. Okay? So we have that there. Couple of little vocabulary words here. We have monotonicity. All right? These are not two graphs. These are, it's not one graph. It's two separate graphs. So this graph here, this graph there, all right? So on this graph, what does this look like? What function would describe this graph? Exponential, maybe exponential growth, all right? This would be exponential decay. And so on this graph, we could have a graph that has increasing or decreasing throughout the whole graph. So this would be a monotone increasing because it's only doing one thing. It's only increasing the whole graph. This would be a monotone decreasing because it's decreasing for the entirety of the graph. It's not necessarily always happens. It could increase and decrease in the same graph. But if it's got monotonicity, then it's only doing one or the other. Only increasing, only decreasing. Okay? We have minimums and maximums that we're wanting to find. All right? Global, or a lot of times you'll hear that referred to as absolute. The global minimum or the global maximum is the highest most or lowest most point on the entire graph. Whatever the domain of the graph is, it's the highest or the lowest. So absolute, global, kind of interchangeable. The local minimum or the relative minimum is only looking at a certain location in the graph, only looking at a certain segment of the graph. Not looking at the whole thing, but just looking in its general area. Most times what we see in a local minimum, a local maximum, we have turning points on the graph. It's changing from one slope to another. Okay? So our local minimums or our relative minimums and maximums are turning points on our graphs. So if we were to look at this picture here. Where would the global min be and where would the global max be? Global min. Where's the global min on the graph?
Point D.
Point D. At 2, -7. -7 is the lowest point on the graph. So the global minimum would be at point B. Okay? Where would the global maximum be?
Okay.
At A, at negative 710 is the highest value. Most times you will only have one global min or one global max. That's all you'll have. Unless there's 2 points that are equal. They're both high. That happens occasionally, but that doesn't happen a whole lot. Okay? So the highest and the lowest. Alright? It's the Olympic champion. Whatever. They're the best in the world. Alright? Or maybe the worst in the world. Got, if you've got a local min or a local max, we're only looking at a certain area of the graph. So we're kind of zooming in. So you're the best in Brian or whatever. Okay? So local minimums. Do we have any local minimums up there? Point B. If I look only in this area of the graph, then that looks like the low point on the graph. So point B is a local minimum. Anything else?
C and E be.
Well,
D would be a local minimum. Now, is it the best overall as well? Could you win competition in Bryan and then go win it for the state? Could you be the same person? That's what D is. It's the local min and it's also a global, it's the global min, okay? So that's that. All right?
you need to specify a domain for that?
Mm-mm.
Oh,
It's just,
looking at the-
just around that area. So
Okay.
if I'm just looking around that area, then, that's relative or that's local, okay? This would probably be a good TOK question or whatever, because we think of things only in our lens. So if only in our relative area, close to us, I'm good.
Wait, so only
I'm
D
the-
would be the local minimum?
Huh?
Only D would be the local minimum?
No, D and B would both be local minimums. Only D would be the global minimum. Okay? Right here, C would be what?
A local max.
A local max. Alright? How about E? Would E fit anywhere? Could it be a local max? Here's the problem. Okay? What's wrong with A and E? Where are they? They're the endpoints, correct? They can be the best. They can be the global or absolute, but they can't really be locals. Because what's the graph doing from here? Do I know where it's going? I'm assuming it's gonna do that, right? But could it do this? So I don't know what's on the other side of this, so it's not, I can't compare it with anything, so I'm not sure. So these endpoints are not really relative because I don't know what's on the outside, and they're not local. Okay? They can be globals, but they can't be relative ones. That make sense? Just because I don't know what exists on the other side. A or E. Okay? All right. Gonna do one last problem with you and we're gonna finish here for the day. So sign charts. So going back to them. So to create a sign chart, the first thing that we want to do is we want to take the first derivative. We're going to set it equal to 0. We're going to find where it's undefined or where it's equal to 0. We're going to find those critical values. Okay? These results are going to give me the possible max and mins. And then we're going to check on either side of them to see what's happening on either side. So this first problem here. I'm going to go take the derivative of this. So the derivative of this would be negative 3x squared plus 6x. By the way, what is a derivative? What does it stand for? Say again. Slope. What did you say? Okay. Yeah, it's the slope of the tangent line. Okay. So this is all about slope. So if I told you I have a positive slope, I know my graph is doing this. If I told you I have a negative slope, I know my graph is doing this. Okay? And so when my graph is 0, what's happening? It's not changing, it's flat. Okay? A lot of times that's where it's changing from positive to negative or negative to positive. So I want to go find where this is equal to 0. So I'll put it equal to 0. How would you solve this right here? How do you know how to solve a quadratic to get it equal to 0? We factor it. If I got two terms, how do we factor two terms?
multiply them.
What do these two things have in common? Greatest common factor. If I only have two of them, what do they have in common?
3x or negative 3x.
Okay, and I would probably take negative 3x out. That would leave me with the x there. That leaves me with the negative 2 there. Okay? So on my number line, when does x minus 2 equal to 0? When x is 2, when it's the opposite. When is negative 3x equal to 0? When it's equal to 0. Okay? So there's my critical values. We kind of did that a while ago. We found it's equal to 0. I'm going to test the areas of this. So I'm probably going to pick negative 1 to test there. I'm going to pick 1 to test there. And I'm going to pick 3 to test there. Again, I'm not concerned with what these numbers are. All I'm worried about is if they're positive or if they're negative. If I plug negative in, negative 1 times negative 3 is a positive. Negative 1 minus 2 is a negative. So I have a positive times a negative. So that's negative. I'll plug the 1 in. Plug the 1 in. That's going to give me negative 3. 1 minus 2 is a negative 1. Negative times negative is positive. Okay? And if I put a 3 in, I get a negative 9. I get a positive 1. Negative times positive is a negative. Okay? Now again, this is derivative, correct? So this is all about slope. This is negative slope. This is positive slope. That's negative slope. Okay? So when it says find the intervals for where this is increasing or decreasing, all right? It's decreasing when the slope is negative. So negative infinity all the way to 0, it's decreasing. It's decreasing again from 2 all the way to infinity. So this graph is decreasing most of the graph. Okay? Where is it increasing? From 0 to 2, right there in the middle. It's positive slope, so it's increasing. So from 0 to 2. Now, one last thing about this. What is this increasing and decreasing? What does that tell me about what's happening at 0? At x equals 0, I had a negative slope and it turned back to a positive slope.
So the slope is 0.
So the slope is 0, but what kind of point is that on my graph? It's a minimum. You see it looks like a minimum there. All right? Decreasing slope back to a positive slope. So I have a minimum at x equals 2. At x equals 0, excuse me. What's happening over here? Got a positive slope to a negative slope, so it's creating a maximum at x equals 2. All right? If the sign doesn't change, can it be a maximum or a minimum? If I go negative to negative, that didn't change. So something else is going on there. So we'll kind of put some more of this together tomorrow. So tonight's homework, it should go pretty quick. Here's what I want. Page 243, we're going to do question number 1. So you're just looking at graphs and you're looking where it's increasing and decreasing. And then on number 2, I just want you to do part A and B on 2. Part A and B will look like what we just did here. Okay?